a replica of the mummy of the Iceman. This will be used for educational purposes. It's a fantastic story in that the Iceman...
Buried beneath layers of ancient ice, a silent figure lay untouched for over 5 millennia, until nature itself began to thaw the past. What appeared to be a tragic mountaineering accident turned out to be something far older and far stranger. In 2025, a final piece of this frozen puzzle was uncovered, revealing startling new details about his life and death. His belongings, his injuries, even the strange markings on his skin, all pointed toward a truth long hidden in plain sight. But one detail in particular stood out, raising new questions. What exactly happened in his final hours, and why does it matter now? Discovery of Utsie the Iceman. In the autumn of 1991, 2 German hikers navigating a glacier in the Utztal Alps near the Austrian-Italian border spotted something startling: a human torso emerging from the ice. At over 3,200 meters above sea level, the high-altitude terrain and melting snow made it seem like a recent mountaineering tragedy. Authorities were called, and initial efforts to recover the body treated the site as a modern crime scene. However, that assumption unraveled quickly, as investigators noted the peculiar condition of the body and the strange artifacts nearby. The corpse was named Utsie after the surrounding mountain range, and it soon became clear he was no ordinary victim of a recent accident. His skin, hair, organs, even his last meal, had been astonishingly preserved by thousands of years of freeze-drying. Unlike most ancient remains, Utsie had not decayed or fossilized. He was essentially locked in time, a natural mummy whose preservation defied expectations. Radiocarbon dating would later place his death at around 3250 before Common Era, making him more than 5,000 years old and the oldest intact mummy ever discovered in Europe. In the beginning, archaeologist Conrad Spindler estimated that Utsie was around 4,000 years old by the style of tools found in the vicinity of his body. However, more precise scientific measures showed that the Iceman was more than a millennium older than that. Among the treasures embodied in material wealth are a copper axe and flint tools, artifacts from the early Copper Age, that period in history when metallurgy started to completely transform society. From his age and the artifacts he carried, the researchers fitted him into a very narrow window in European prehistory. The first indication of a seemingly unscathed grave actually turns out into something quite more undulating. Scientists who have worked on the moss and vegetation from the gully where Utsie was found find that the ice had thrice melted and refrozen over many hundreds of years. In this event, it has been proven that glaciers do not necessarily preserve in one freezing. Rather, ancient remains can get exposed and then reburied in the course of weather changes. This has directly contributed to the emergence of an entirely new field called Glacial Archaeology, sparked from Utsie's silent witness to history. What truly stunned scientists wasn't just how old he was, it was how perfectly time had held him still. Natural mummification versus Egyptian mummification. Utsie's preservation represents a rare case of natural mummification, in which environmental conditions alone preserved his body in extraordinary detail. Unlike traditional burial or intentional mummification, Utsie's corpse underwent a unique freeze-drying process caused by the extreme cold, low humidity, and occasional exposure of the high alpine gully where he died. His body was not embalmed, wrapped, or altered. His tissues, skin, and even stomach contents remained virtually untouched since the day of his death over 5,000 years ago. In contrast, the ancient Egyptians perfected artificial mummification as a ceremonial and spiritual practice. Their process involved removing internal organs, dehydrating the body with natron salt, and sealing it with resins and linen wrappings. Egyptian mummies were intentionally preserved for religious reasons, to secure the soul's passage to the afterlife. This was an elaborate, time-consuming ritual reserved for the elite and carried deep cultural significance, emphasizing the Egyptian belief in life beyond death. These different approaches have given rise to very different preservation results. While normally well-preserved, Egyptian mummies often possess hollowed cavities and desiccated tissues, with varying degrees of damage from time and the embalming process. Utsie, on the other hand, has been able to retain his body organs, muscle tissues, and, in some instances, skin coloration, to allow researchers to conduct molecular studies, scan his arteries, detect tattoos, and study his last meal, all to an accuracy rarely performed on ancient human remains. The contrasts between Utsie and Egyptian mummies would change the way scientists think about preservation and the ability of the natural environment to retain clues to the past. Utsie's body was never supposed to survive, but it survived due to nature alone. The Egyptian mummies are all about ritualistic and symbolic preservation, while the natural preservation of Utsie's body makes it a true scientific time capsule. It provides insight into daily life, health, and death in prehistoric Europe, without the layers of ceremonial considerations that accompany intentional mummification. Tools and artifacts found with Utsie. Utsie's burial site was not only home to an ancient human body, it also preserved a full inventory of his tools, gear, and personal items, offering a glimpse into the life of a Copper Age traveler. Among the most fascinating items was his copper-bladed axe. Forged from nearly pure copper and mounted on a wooden handle using birch tar, the tool revealed that Utsie lived during a technological turning point when humans began replacing stone implements with metal ones. Such a high-quality item suggested both skill and status, hinting at Utsie's possible role within his community. Near his body, archaeologists uncovered a partially constructed longbow and a quiver containing 14 arrows, some finished with flint heads and fletching, while others remained incomplete. This mix suggests he was preparing new equipment, possibly in response to conflict or a hunting mission. The bow was made of yew, a strong and flexible wood that was ideal for archery, while the arrows were crafted with sharp stone points and bound with natural sinew. These weapons weren't ceremonial, they were tools for survival and possibly defense. These included within-the-frame items like a small flint dagger in a wooden sheath, a leather pouch that had several compartments like a scraper and an awl, and an inch or a remnant of a wooden frame that formed part of a possible backpack. These appear to indicate the mobility, practical skills, and equipment with which Utsie was ready for life on the move in mountain harshness. Each item reflects his personal resourcefulness, as well as a broad understanding of toolmaking and materials held by early societies in Europe. Even the smallest in terms of size item, here represented, is the birch fungus he carried, presumably for medicinal use, which provides further insight into the Copper Age mind. Taken together, these artifacts paint a striking portrait of someone well-provisioned for travel or hunting in a mountainous environment. They suggest that Utsie was not just wandering, but perhaps involved in a purpose, a journey of fleeing or preparing to do so in confrontation. His sophisticated gear takes on earlier assumptions about prehistoric technology. Humans had already developed, even 5,000 years ago, incredibly complex, multifunctional toolkits designed for their environment and challenges all along. Unraveling the mystery of his death. When Utsie was first recovered, scientists believed he had died of hypothermia after being caught in a sudden alpine storm. This early theory was logical, given the remote location and extreme elevation of his final resting place. Archaeologist Conrad Spindler speculated that Utsie had fled a violent encounter and collapsed from exhaustion in the gully where his body froze. Supporting this theory were clues such as broken arrows and an unfinished bow, which suggested a hasty departure from lower elevations. However, new forensic technologies would soon contradict the idea of a peaceful, cold-induced death. In 2001, X-ray imaging revealed a small but critical clue: a 13mm arrowhead lodged between Utsie's left shoulder blade and rib cage. The arrow's wooden shaft had snapped off, likely going unnoticed during earlier investigations. Closer inspection of the tissue revealed that the arrow had entered his back and had not begun to heal, indicating a recent and fatal injury. The true cause of death was no longer a mystery of the elements, but one of sudden and violent trauma. CT scans provided further evidence, with the arrow penetrating through Utsie's subclavian artery, the blood vessel below the collarbone. Rapid internal bleeding followed. The additional factor for supporting this conclusion was the detection of fibrin, a protein that appears immediately at the few wound sites and disappears shortly after. In fact, the very presence of fibrin would suggest that Utsie's body started some reaction to the trauma, but could not pull through in a full clotting mechanism since he died almost instantaneously. So the evidence now transformed Utsie's story from a case of tragic accident to one of deliberate slaying. Gifted with sharp stone points and bound with natural sinew, these weapons weren't. The wounds tell the tale further. The deep cut to the hand fits as a defensive injury sustained possibly a few days prior to death. So, there must have been some fighting going on shortly before the arrow struck him fatally, adding drama and humanity to his last hours. Far from dying peacefully in the snow, violence, desperation, and movement filled Utsie's last moments, an attempted escape that barely missed success. The new forensic revelations have, thus, refocused attention on Utsie as more than just a historical figure, but also as a victim, one of the oldest unsolved homicide cases on record. DNA evidence and ancestry. Utsie's preserved tissues offered a rare chance to peer into the genetic makeup of a prehistoric individual, and the results from his DNA analysis have reshaped our understanding of ancient European populations. In 2012, researchers conducted an initial sequencing of his genome and believed he shared a close genetic connection with modern-day Sardinians. This led scientists to hypothesize that Utsie's ancestors may have migrated from Mediterranean regions, contributing to early European agricultural communities. The reconstruction of his appearance in the South Tyrol Museum was based on this interpretation, portraying him with fair skin and shoulder-length graying hair. A decade later, improved sequencing techniques provided a more accurate genetic profile, correcting earlier misinterpretations. It turned out the original DNA sample had likely been contaminated by modern human contact. When scientists reanalyzed uncontaminated material using next-generation sequencing, they discovered that Utsie's true ancestry pointed to ancient Anatolian farmers who had migrated from what is now the Asian part of Turkey. These early farming communities played a major role in shaping Europe's Neolithic population through migration and cultural exchange. Utsie's lineage thus places him within a broader migratory narrative that connects the Near East to early European settlement. The current genetic analysis has also provided a lot of insights about the physical form and biological characteristics of Utsie. Unlike the earlier reconstructions, the authentic lines suggested that it has dark, bronzed skin and genetically stands to lose hair at an early stage, as with male pattern baldness. The hair was probably sparse rather than shoulder length. Thus, the skin color was also not the result of unending freeze-drying, but it was believed to be the true complexion. Such results would change pictorial stereotypes in the eyes of prehistoric Europeans and actually give a very similitude of the Copper Age people. Utsie's genome told even more about his health. Genetic markers for lactose intolerance and cardiovascular disease indicated possible issues with diet or circulation. Even more surprising was the DNA from Borrelia burgdorferi, the bacterium responsible for Lyme disease, making him the earliest human known to have carried this infection. These genetic traces of pathogens, physical predispositions, and inherited traits give scientists a comprehensive look at the ancient human condition, showing that Utsie's body is more than a time capsule. It's a biological archive of prehistoric life. As revealing as his DNA was, The clues locked inside his stomach painted an even more vivid picture of his final days. Diet and health in the Copper Age. The preservation of Utsie's stomach was initially overlooked due to its displacement beneath his rib cage by post-mortem glacial pressure. Once identified, however, it opened a new dimension in the study of prehistoric diet. Scientists examined the contents of his stomach and intestines, revealing a well-rounded final meal that included ibex meat, red deer, and einkorn wheat, an ancient grain cultivated in early farming societies. Traces of charcoal suggested the meat was cooked, possibly smoked over an open flame, indicating Utsie had access to both fire and the tools necessary for food preparation, even while traveling. Beyond what he ate, the microscopic analysis of Utsie's stomach contents shed light on his movements before death. Pollen and spores, found in varying stages of digestion, revealed that he moved across different altitudes in a short period. For example, pine pollen found deep in his digestive tract indicated a meal at a lower forested zone, while later ingested plant spores suggested he climbed back up to the alpine zone where he ultimately died. This rapid elevation change aligned with other evidence pointing to urgent travel, perhaps flight from danger or pursuit of shelter. It has also been shown that these remains brought about significant health problems. He suffered from whipworm infestation, a fishworm infestation disease known for causing gastrointestinal trouble and inflammation. Furthermore, the discovery of Helicobacter pylori has early signs of chronic, thereby adding to this condition evidence of ulcers and a gastric cancer-causing microbe. This makes it easy to determine that this ancient individual suffered from chronic infections. The proteins linked with immune response to H. pylori were still present, indicating that, most probably, the individual had recently experienced pain or was in distress from digestive issues just before dying. This illustrates that even the most excellent diet could not spare prehistoric inhabitants from disease. That is giving an insight diet and health could have had for such an individual suffering from the life of the Copper Age. These meals reflected his efforts to balance farming and hunting, with the infections of the time showing little ahead in medical knowledge. This was made more than 5,000 years ago to create a very vivid picture of daily life with this data. The body of Utsie tells one not only how people fed themselves, but also how they connected with the daily conditions, including how these may have impacted what happened in their final days. Utsie's dietary profile also provides insight into some of the greater cultural and environmental adaptations of his time. Grains and wild game in his diet reflect a changeover period in the history of humankind when communities were in the process of transitioning from fully nomadic hunting to settled farming lifestyles. Similar archaeological evidence for mixed subsistence strategies has been recovered from alpine settlements nearby, illustrating Copper Age societies employing seasonal mobility to optimize the exploitation of food sources. In addition, the occasional inclusion of high-fat ibex meat in his final meal is a testament not only to nutritional knowledge, but also to fitting adaptation to the climatic factors of cold altitude, where energy-dense food was crucial for survival. Ancient tattoos and medical practices. Among the most remarkable features of Utsie's preserved body are his 61 tattoos, simple geometric markings etched into his skin using charcoal and small incisions. Unlike modern tattoos, which often serve aesthetic or personal purposes, Utsie's markings appear in places typically hidden beneath clothing. Most consist of straight lines, crosses, and clusters of dashes, and they are concentrated on areas of the body that also showed signs of physical strain or degenerative joint disease, including the spine, knees, ankles, and wrists. What makes these tattoos especially fascinating is their potential connection to early medical practices. X-ray imaging revealed that many tattooed areas corresponded to joints affected by arthritis, prompting researchers to hypothesize that the tattoos may have served a therapeutic function. Some scientists believe these markings were part of a rudimentary form of acupuncture or pain relief, a technique aimed at targeting pressure points to ease chronic discomfort. While no needles or medicinal implements were found with Utsie, the strategic placement of the tattoos suggests deliberate treatment. The process from which tattoos came was clearly simple. Coal was rubbed into cuts fine enough for the pigment to dry and last for millennia. Although dissimilar from contemporary tattooing, this displayed an understanding of how permanent markings could be made on the body. All the necessary materials were completely natural, easily available in Utsie's environment. Early humans could create long-lasting body art using their resources without specialized tools. They are more than mere adornments. The repetitive pattern and specific areas imply a knowledge transmitted experientially rather than through an institutionalized study of science. In the highly unlikely case, tattooing could be among the earliest forms of body-enabled medical intervention. Healing rituals, symbolic practices, or functional therapies of pain might have incorporated the existing artwork, marking a society that involved itself meaningfully with the corporeal. Within these, prehistoric modern gaps were traversed, sitting near that threshold between history and prehistory, via way of these tattoos through medicine. It provides evidence that the experiments dealing with physical remedies happened long before anything was written down. They also show that pain management, as well as bodily care, were even the earliest issues of human societies. Utsie's tattoo is regarded with a great deal of interest, as it has resulted in comparisons with those traditional tattooing West that considered body art and healing rituals, both of which have had histories of such. For instance, Inuits of the Arctic and the Ainu of Japan have long employed hand-poked tattoos not only as markers of identity and social status, but also to treat specific maladies, something akin to the healing theory suggested for the case of Utsie. Lars Krutak, an anthropologist who has investigated traditional tattooing from a comparative perspective, tattoos in ancient societies often functioned as symbolic, spiritual, and medical tools. Such a wider anthropological approach implies that Utsie's tattoo is part of a larger human tradition, wherein the body acted both as canvas and quartzi, radiocarbon dating and DNA sequencing. Unraveling Utsie's story would not have been possible without the use of advanced forensic science. One of the first and most crucial techniques applied was radiocarbon dating, which measures the decay of carbon-14 isotopes in organic material. This method allowed scientists to determine the age of Utsie's remains with remarkable precision. Since carbon-14 decays at a known rate, with a half-life of 5,030 years, comparing the ratio of carbon-14 to stable carbon-12 in Utsie's tissues confirmed that he died around 3250 before Common Era, placing him in the early Copper Age. To go further, scientists turned to DNA sequencing to uncover his genetic blueprint. The process began with polymerase chain reaction, PCR, a technique used to amplify tiny amounts of ancient DNA into millions of readable copies. Utsie's DNA, though degraded by time, was carefully extracted from his bone and tissue samples. PCR made it possible to isolate and multiply specific sequences of interest, enabling further analysis, even from tiny fragments that would otherwise be unreadable. It was then that Sanger sequencing was applied for the first time to the amplification products of all DNA fragments using fluorescent markers to identify the order of base pairs: adenine, cytosine, guanine, and thymine. Modified nucleotide DNTP was incorporated in the reaction during PCR to selectively truncate the DNA strands at various points. The resulting fragments were separated by size using a capillary gel electrophoresis system that employed electric current to pull DNA through a gel. From the movement pattern and fluorescence, scientists reconstructed an astonishingly clear genome for Utsie. These technological tools have reshaped not just Utsie's case, but also archaeological science as a whole. Radiocarbon dating secured Utsie's temporal position in history. DNA sequencing made clear his ancestry, appearance, diet, and diseases. Together, They have turned a frozen carcass into a living data set that can now be input into studies of prehistoric genetics, migration, and health. Utsie's case demonstrates a synergy of traditional archaeology and modern molecular biology, thus beginning to answer some of humankind's oldest questions. Utsie's case is compelling, truly, as it demonstrates the growing intersection between forensic technology and local public interest in personal genetics. As DNA sequencing becomes cheaper and cheaper, forensic tools once only usable in elite scientific labs are now available within consumer ancestry kits and controversial medical diagnostics. Genome sequencing was a precursor to that, providing a real-life demonstration of the power of genetic information in reconstructing personal identity and history. With Utsie, we saw how DNA can speak for the dead, how it brings to life stories no one knew were hidden in our cells, said Dr. Albert Zink, head of the Institute for Mummy Studies in Italy. In case there's a perfect illustration of how ancient DNA can connect the past with the present, that is adding its own answers to scientific questions, but also opening a whole new forum through which contemporary concerns could have resonance about ancestry, health, and identity. The rise of glacial archaeology. Utsie's discovery didn't just rewrite ancient history, it sparked the creation of an entirely new scientific discipline: glacial archaeology. Before 1991, few researchers had seriously considered that glaciers could preserve human remains and cultural artifacts in such remarkable condition. Utsie's naturally freeze-dried body, along with the tools and organic materials around him, opened the eyes of archaeologists to the potential buried within the ice. His case proved that glacial environments weren't just destructive forces of nature, they were also cold vaults, preserving chapters of human history. This realization transformed how scientists approached alpine and Arctic regions. Rather than treating these environments as barren, they began investigating melting glaciers as active archaeological sites. A critical breakthrough came when researchers radiocarbon-dated moss and leaves found in the same gully as Utsie. These materials, deposited over centuries, indicated that the glacier had thawed and refrozen multiple times, challenging the assumption that Utsie had remained sealed in ice continuously since his death. This discovery introduced the concept of dynamic ice environments, where ancient materials could be exposed, lost, or re-encased across centuries. Since then, glacial archaeologists have uncovered a growing array of artifacts from melting ice fields in various corners of the world. In those same areas in Norway, Yukon in Canada, and widely throughout the Alps, items such as wooden tools, leather garments, and even more human remains have emerged from thawing ice. These finds provide unique insight into the everyday lives of people from cultures that have otherwise left little in the way of traditional archaeological deposits. As these objects continue to be exposed by warming temperatures, glacial archaeologists must get to work to document and preserve them from decay once they come into contact with the open air. Glacial archaeology has stimulated collaboration among climatologists, geologists, and anthropologists. Now, with people like Andreas Putzer, conservator at the South Tyrol Museum of Archaeology, leading teams of active high country scouts that spend summers searching for evidence of early human settlements, visibility has been given to more than disciplined and intellectually constricted segments. These expeditions are coordinated to investigate sites near water sources, vegetation, and shelters likely to have supported life thousands of years ago. Had it not been for the discovery of Utsie, this interdisciplinary approach to ice archaeology might never have seen the light of day. He became a kind of scientific phenomenon, and also the accidental founder of a new frontier in historical inquiry. Glacial archaeology isn't really good for learning only. It changes the ways that people, such as indigenous communities and the broader public, connect themselves to their past. An example is melting ice in the Yukon Territory, revealing ancient hunting implements associated with the ancestors of modern First Nations peoples. The Champagne and Aishihik First Nations work with archaeologists on these projects and join them in recovering, interpreting, and preserving artifacts. Quite a lot of participation. Now, those aren't just archaeological finds, said Geraldine Charlie, a cultural heritage worker at the Yukon. They're part of our story, tools from our ancestors, our reminder of how we lived on the land. This is the collaboration associated with recognizing that the practice of glacial archaeology is ethically accountable to living cultures in consideration of the ancient ones being found. Yet, as more secrets emerge from the ice, a troubling new reality begins to surface. The future of ice discoveries. While Utsie's discovery opened a new chapter in archaeological science, it also served as a foreshadowing of a much larger and more urgent phenomenon: how climate change is unlocking and endangering the ancient past. As global temperatures rise, glaciers are melting at unprecedented rates, revealing objects that have remained hidden for thousands of years. This includes everything from hunting tools and clothing to bones and plant matter, preserved in conditions once ideal for long-term survival, but now increasingly unstable. One of the key scientific revelations from Utsie's find was that even in the high Alps, seasonal thawing has occurred for millennia. Radiocarbon dating of vegetation at the site confirmed that the ice had melted and reformed several times, allowing organic material to shift, settle, or even resurface. But today's warming trend is different. It's faster, more intense, and more widespread, putting the fragile remnants of ancient life at serious risk. Items that emerge from melting ice are often exposed to sunlight, oxygen, and microbial activity for the first time in centuries, accelerating their decomposition. With protests, scientists and conservation crews are now racing against time. Glacial archaeology flourishes with the discoveries, but the shaded breadth of yet safely recovering and studying these materials is becoming narrower with each passing day. Entire ecosystems of history melt away even before proper documentation can be carried out. Thus, archaeologists have prioritized melt zones that are judged to be high risk and high gain. They predict where the next big event might happen and therefore quickly mobilize as soon as something is reported using satellite images, climate models, or drone surveys. The implications go way beyond archaeology, though. Every item, clothing, seeds, or bacteria, preserved gives clues about former weather patterns, agriculture, and health conditions. The example of Utsie proves that not only are these finds a cultural asset, but these ice-bound trophies are also climate records themselves. A pressing question arises for scientists with global warming. How much of this ancient world could be saved, studied, and presented to the world before it is forever hidden under melting glaciers? Norse glacial archaeology teams reported the finding of a wool tunic near the Lendbreen ice patch in 2017, a rare find that was to garner world attention after being dated to 1,700 years. More interestingly, the wool tunic had been preserved well in the Lendbreen ice and was presumed lost or discarded by someone who had been crossing the mountain pass in antiquity. This is not just an artifact. It is a frozen moment in time, says Lars Pihlur, an archaeologist who is co-directing the Norwegian Secrets of the Ice project. Such discoveries have prompted new ethical conversations in the area. Should these objects stay in their natural resting places, or should they be removed and kept in museums before disappearing? The melting glaciers and the exposure of globally wondrous treasures have gotten in line with both sides of a call. Preservation versus intervention, echoing an age-old question: how do we reconcile scientific curiosity with the needs imposed by environmental change? Thanks for watching. If you found Utsie's story as fascinating as we did, don't forget to like the video, leave a comment with your favorite theory, and subscribe for more ancient mysteries and science breakthroughs. Want to keep exploring? Click the next video on your screen. We've got more mind-blowing discoveries waiting for you. See you there.